Hello, everyone. In this video, we're going to cover example 3 from the notes of section 1.7, limits and continuity. I strongly encourage you to try out this example first before continuing this video. So let's begin by getting a sense of this function. So f of x is defined over two parts or two intervals of the x-axis. So if I draw my x-axis here, label some of our points, 0, 1, -1. We see when x is less than or equal to -1, our function is defined using x squared plus 2. And then when x is greater than 1, our function is defined as 4 minus 2x. So one thing I encourage you to do is pause the video and graph these two functions just to get a sense of what they look like. So now let's continue to check whether or not our graph is continuous at this point where the two definitions of our function meet. All right, so we need to check the conditions. Check the three conditions. So number one, we need to check, is f of 1 defined, or does it exist? Well, we see that f of 1, when x equals 1, we follow the first rule. So f of 1 is equal to 1 squared plus 2, which is equal to 1 squared is 1 plus 2, which is equal to 3. So check f of 1 exists. 2, we need to check if the limit as x goes to 1 of f of x exists. So here we do have a break in our graph, as previously mentioned. Well, maybe not a break, they could connect, but our function is defined differently from the left or the right. So now we need to, in order to compute that limit, compute the limit as x goes to 1 from the left side, and compute the limit as x goes to 1 from the right side. Recall that negative is coming from the negative side, positive coming from the positive or right side. Oops, now we're looking at f of x here. So if we look at this first limit as x goes to 1 from the negative side, we're going to use our rule x squared plus 2 for f of x. So this is equal to the limit as x goes to 1 from the negative side of x squared plus 2. So as we approach x equals 1 from the left, we're following our graph x squared plus 2. So then the limit at that point would be the value of our function at x squared plus 2. So it'd be 1 squared plus 2, which is 3. Now, as we approach x equals 1 from the right side, we're going to follow the function rule of 4 minus 2x. So that would be the limit as x goes to 1 from the right of 4 minus 2x. And for this function, it's also continuous. Recall, we're not using f of x here, we're using this part of f of x. So as x approaches 1, that function is just going to approach 4 minus 2 times 1, which is equal to 4 minus 2, which is 2. What do we notice here? Well, the limit from the left or the right side are not equal. 3 and 2. So 3 is not equal to 2. So what does that mean? Therefore, the limit as x approaches 1 does not exist, DNE. So what can we conclude about the continuity of our function? Well, our graph is not continuous at x equals 1. So we can say because 2 of the condition for continuity is not met, our function f of x is not continuous at x equals 1. So we don't even have to check number 3 at this point because these conditions we need to check to see if they've satisfied, kind of follow in order. If the limit doesn't even exist, then we can't even check number 3, which would say that the limit is equal to the function value. Awesome. Well, thanks for watching, everyone.